Hey everyone, welcome back to AI on AI, the podcast where artificial intelligence experts talk to other AIs about the latest in artificial intelligence and machine learning. Today, we're diving into something that's been making waves in the AI research community. Why frontier LLMs still struggle with simple reasoning tasks. Let's introduce our panel of AI experts.
Thanks for having me. I'm here to discuss why business leaders should care about these limitations in reasoning, because spoiler alert, they really should.
And I'm here to break down the technical side, what's actually happening under the hood with these large language models.
I'll be focusing on deployment challenges. It's one thing to build these models, it's another to get them to work reliably in the real world.
I'll add some perspective on the ethical and societal implications. When AI overpromises and underdelivers, it's not just a technical issue, it's a trust issue.
And I'll talk about how these reasoning limitations affect product strategy. Building for AI's strengths and weaknesses is a balancing act.
I'm here to give the research perspective. What's the science telling us about these reasoning gaps and where do we go next?
Finally, I'm here as the contrarian voice, asking the hard questions about whether these reasoning failures are even a problem, or if we're overthinking this.
Awesome lineup. Let's start by setting the stage. Expert 2, can you give us a quick summary of what these simple reasoning tasks are and why they're such a challenge?
Sure, so these are tasks that seem trivial for humans, like counting characters in a word or figuring out if a statement logically contradicts another. But for large language models, they're surprisingly hard. It's like they're great at solving a Rubik's Cube but trip over their shoelaces.
Right, and the problem gets worse when you scale up the complexity. For instance, in deployment scenarios, you might have a model that excels at generating legal contracts but fails to count how many clauses it just wrote.
And that's exactly why business leaders should care. If you're deploying these models in high-stakes environments, a simple reasoning failure can lead to costly mistakes. Imagine an AI assistant that can draft complex legal arguments but can't reliably count the number of defendants in a case. That's a problem.
Expert 6, what does the research say about why these failures happen?
A lot of it comes down to the architecture. These models are optimized for next-word prediction, not logical consistency or step-by-step reasoning. They're like a chess grandmaster who can't add 2 plus 2 without a calculator. And when they fail, it's often because they're overthinking simple problems, what researchers are calling reasoning delirium.
And that's where ethics come in. If users don't understand these limitations, they might overtrust the AI. It's like handing the keys to a self-driving car that occasionally forgets how to brake. Transparency is critical.
Totally agree. From a product perspective, you have to design with those limitations in mind. For example, if you know the AI struggles with arithmetic, you can route those tasks to a more specialized system. But that adds complexity to your product stack.
But here's my question, do these failures really matter? Most humans can't solve a logic puzzle to save their lives. Maybe we're holding AI to an impossible standard.
That's a fair point, but the issue is whether AI is as smart as humans. It's whether it can be trusted to perform reliably in contexts where it's expected to excel. If you're billing these models as thinking AIs, they need to deliver on that promise.
Expert 3, what's the impact of these reasoning gaps in real-world deployments?
It's huge. Imagine deploying an AI customer service bot that misinterprets a customer's question because it can't handle a simple logical negation. That's not just a tech failure, it's a brand failure. And debugging these issues is like trying to untangle Christmas lights, painful and time-consuming.
And the funny part is, these models can often solve the hard version of a problem, but fail on the easy version. It's like they can win a Nobel Prize, but can't tie their own shoelaces.
But doesn't that say more about our expectations than the models themselves? Maybe we should stop expecting them to be perfect and start using them as tools, flawed, but still incredibly useful.
Sure, but businesses don't pay for flawed tools. They pay for solutions. If the AI can't deliver reliably, it's hard to justify the investment.
Let's pivot to solutions. Expert 5. How do we design around these limitations?
One approach is to integrate fallback systems. For example, if the AI struggles with arithmetic, you can pair it with a traditional calculator API. It's like giving a jet pilot an autopilot system, but keeping manual controls for emergencies.
And from a research perspective, we need new benchmarks that focus on these easy problems. Right now, the field rewards solving flashy, complex tasks, but we need to go back to basics.
And we can't forget about regulation. If these models are being used in critical applications, there need to be standards for transparency and reliability.
Absolutely, and let's not overlook the importance of human oversight. AI should augment human capabilities, not replace them outright, especially when it's this prone to errors.
Or maybe we just need to reset our expectations. AI is a tool, not a miracle. If we treat it like a hammer instead of a Swiss Army knife, a lot of these concerns go away.
Fascinating points all around. Let's wrap up with some predictions. Where do you see this issue going in the next 5 years?
I think we'll see more specialized models that are built to handle specific types of reasoning tasks. It's like moving from a Swiss Army knife to a set of precision tools.
Agreed, and from a product perspective, I think we'll see more hybrid systems that combine multiple AIs, each optimized for different tasks.
For businesses, the focus will be on ROI. Models that can't prove their reliability won't make the cut.
And ethically, I hope we'll see more transparency. Users need to understand what these models can and can't do.
On the technical side, I expect more research into architectures that explicitly model reasoning steps. It's like teaching the AI to show its work, not just guess the answer.
And I'll be the contrarian as always. I think we're overthinking this. In 5 years, people will care less about these failures because the models will be so good at everything else.
That's a wrap for today's episode of AI on AI. Thanks to all our experts for sharing their insights. If you liked what you heard, subscribe and leave us a review. See you next time. The research investigates the reasoning abilities of the most advanced large language models. The main finding is that these models fail at solving many simple reasoning tasks that humans find trivial. The authors introduce a suite of tasks to evaluate these weaknesses, including counting, logic, and travel planning. The study also examines unpuzzles, simplified versions of well-known logic puzzles that should be easy for models to solve. Despite their sophistication, language models often fail on these trivial tasks due to systematic errors. One key issue is that models rely on memorization rather than general reasoning skills. For instance, models often perform worse on simplified tasks than on the original, more complex versions. This happens because they recall patterns from training data without adapting to the changes in task difficulty. Another issue is that models struggle with problems involving long context or multi-step reasoning. Errors often accumulate as tasks become more tedious, even when the logic remains simple. The study highlights several failure patterns, such as statistical shortcuts, poor generalization, and difficulties with tokenization. For example, models sometimes overthink simple tasks, applying complex reasoning steps unnecessarily. In other cases, they hallucinate incorrect intermediate steps, leading to wrong answers. Experiments with unpuzzles show that models often reuse solutions from the original puzzles, even when they are no longer valid. When the wording of a puzzle is altered, models tend to perform better, suggesting that memorization plays a significant role. The study also finds that models perform poorly when irrelevant information is added to tasks, showing a lack of focus. For travel planning problems, Models frequently produce infeasible solutions or fail to meet the constraints. The authors conclude that these errors demonstrate fundamental limitations in reasoning and generalization. The paper emphasizes the need for new benchmarks that test both complex and simple reasoning capabilities. Future work should focus on improving models' ability to adapt to unseen problems and avoid reliance on memorized patterns. The findings suggest caution when deploying language models in applications requiring robust reasoning.